Our sun is just one star among billions in the Milky Way galaxy. The Milky Way itself is just one galaxy among billions more. Imagine a grain of sand on a vast beach. That's how insignificant our sun is in the grand scheme of the cosmos. Now, imagine another beach far away representing another galaxy. The distances between these galaxies are almost impossible to grasp. Could we ever journey to these distant islands of stars? The challenges are immense, but the human spirit of exploration always pushes the boundaries of what's possible. The speed of light is the fastest anything can travel in the universe. This speed, often denoted by the letter c, is a cornerstone of modern physics, and has profound implications for our understanding of the cosmos. It's a fundamental law of physics. According to Einstein's theory of relativity, nothing with mass can reach or exceed the speed of light. This principle shapes our understanding of space, time, and energy. Light travels at an incredible speed of approximately 299,792 kilometers per second. To put this into perspective, if you could travel at the speed of light, you could circle the Earth more than 7 times in just 1 second. Even at this speed, it takes years for light from nearby stars to reach us. For instance, the light from our closest star, Proxima Centauri, takes about 4.24 years to reach Earth. This means we are always looking at the past when we observe the stars. When we talk about the distances between galaxies, we have to use a unit of measurement called a light year. A light year is not a measure of time, but of distance. It represents how far light travels in 1 year. 1 light year is the distance light travels in a year, which is about 9.46 trillion kilometers. This vast distance helps astronomers measure the incomprehensible expanses of space. To put this into perspective, the nearest galaxy to our own, Andromeda, is about 2.5 million light-years away. This means the light we see from Andromeda today actually left the galaxy 2.5 million years ago, long before humans even existed on Earth. The speed of light also limits how we explore the universe. Even with our most advanced technology, sending a spacecraft to another star system would take thousands of years. This cosmic speed limit challenges our ambitions for interstellar travel. Scientists are exploring theoretical concepts like wormholes and warp drives, which could potentially allow faster-than-light travel. However, these ideas remain speculative and face significant scientific and technological hurdles. For now, the speed of light remains an unbreakable barrier, a constant that defines the structure of our universe. It reminds us of the vastness of space and the incredible scales of time and distance that govern the cosmos. As we continue to explore and understand the universe, the speed of light will remain a fundamental concept, guiding our discoveries and shaping our quest to unravel the mysteries of the cosmos. Our current rockets, while impressive, are simply not fast enough for intergalactic travel. Chemical rockets, which burn fuel to produce thrust, are how we currently get to space. These rockets are incredibly powerful, but they are limited by the amount of fuel they can carry. Even if we could travel at the speed of our fastest spacecraft, it would still take us millions of years to reach another galaxy. To put that into perspective, that's longer than the entire history of human civilization. We need a fundamentally different approach to propulsion if we want to conquer the vast distances between galaxies. One of the strangest and most fascinating consequences of Einstein's theory of relativity is the phenomenon known as time dilation. This concept has intrigued scientists and the general public alike since it was first proposed. Time dilation means that time is not experienced at a constant rate for everyone. Instead, the rate at which time passes can vary depending on the relative speed of the observer and the object being observed. This means that two people moving at different speeds will experience time differently. For instance, time passes slower for objects that are moving at very high speeds relative to a stationary observer. This effect becomes more pronounced as the speed of the moving object approaches the speed of light. So if we could travel at speeds close to the speed of light, time would slow down for us relative to people on Earth. This means that while years might pass for those on Earth, only a few months or even days might pass for the travelers moving at such high speeds. Imagine embarking on a journey to a distant star system. To an outside observer, this journey might take millions of years. However, for the travelers on the spaceship, the journey might only feel like a few years, or even just a few months, depending on their speed. However, achieving these incredible speeds is a challenge we have yet to overcome. The technological and energy requirements to reach such velocities are currently beyond our capabilities. Scientists and engineers are continuously working on innovative solutions to make high-speed space travel a reality. One of the key areas of research is developing propulsion systems that can achieve a significant fraction of the speed of light. Concepts such as ion drives, nuclear propulsion, and even antimatter engines are being explored. Each of these technologies presents its own set of challenges and potential breakthroughs. Ion drives, for example, offer a highly efficient means of propulsion, but they currently lack the thrust needed for rapid acceleration. Nuclear propulsion could provide the necessary power, but it comes with significant safety and engineering hurdles. Antimatter engines, while theoretically possible, require the production and storage of antimatter, which is an enormous challenge in itself. Despite these challenges, the dream of high-speed space travel continues to inspire scientists, engineers, and dreamers around the world. The potential to explore distant star systems, discover new worlds, and perhaps even find signs of extraterrestrial life drives the relentless pursuit of these advanced technologies. As we continue to push the boundaries of our technological capabilities, each small step brings us closer to making the dream of interstellar travel a reality. The journey may be long and fraught with challenges, but the glimmer of hope that Einstein's theory of relativity provides keeps the flame of exploration burning bright. With each passing day, we move closer to a future where the stars are within our reach, and the mysteries of the universe are ours to explore. The adventure of a lifetime awaits, fueled by the relentless curiosity and ingenuity of the human spirit. Section 5. Wormholes and warp drives, science fiction or future reality. The idea of wormholes and warp drives captures the imagination. These concepts have been popularized by countless science fiction books, movies, and TV shows, painting a picture of a future where interstellar travel is as easy as hopping on a plane. But how close are we to turning these fantastical ideas into reality? A wormhole, in theory, is a shortcut through space-time. It's a hypothetical tunnel-like structure that connects two separate points in space and time, potentially allowing for faster-than-light travel. The concept was first proposed by physicists Albert Einstein and Nathan Rosen in 1935, hence the term Einstein-Rosen bridge. Imagine folding a piece of paper so two distant points touch. This analogy helps to visualize how a wormhole might work. If you could fold space-time in such a way, you could theoretically travel from one point to another instantaneously, bypassing the intervening space. A wormhole would be like a tunnel connecting those points. However, creating and stabilizing a wormhole would require exotic matter with negative energy density, something that has yet to be discovered or understood. A warp drive, on the other hand, would involve manipulating space-time itself, creating a bubble around a spacecraft. This concept was popularized by the Star Trek series and is based on the idea of compressing space in front of the ship and expanding it behind, effectively allowing the ship to move faster than light without violating the laws of physics. This bubble would compress space in front of the ship and expand space behind it. The ship itself would remain in a locally flat region of space-time, avoiding the relativistic effects of near light-speed travel. Theoretical physicist Miguel Alcubierre proposed this idea in 1994, but it remains purely theoretical due to the enormous amounts of energy required. However, these concepts remain firmly in the realm of science fiction. Despite the tantalizing possibilities, we are far from achieving the necessary breakthroughs in physics and engineering to make them a reality. The energy requirements alone are staggering, and we currently lack both the materials and the understanding to create and control such phenomena. We currently lack both the theoretical understanding and the technological capability to create them. Scientists continue to explore the boundaries of our knowledge, hoping that one day we might unlock the secrets of the universe and turn these science fiction dreams into future realities. Until then, wormholes and warp drives remain fascinating topics for speculation and inspiration, fueling our imagination and driving our quest for knowledge. Section 6. The challenges of interstellar travel, radiation, and resources. Even if we could overcome the speed limit, space is a dangerous place. The space between galaxies is not empty. It's filled with cosmic radiation and interstellar dust. Cosmic rays are high-energy particles that can damage electronics and living tissue. Additionally, a spacecraft traveling to another galaxy would need to be entirely self-sufficient. It would need to generate its own energy, grow its own food, and recycle all of its resources. This presents a huge engineering challenge. Section 7. The human factor. Can we survive the journey? Let's not forget the human element. Could humans, both physically and mentally, withstand a journey that might last for generations? The psychological effects of confinement, isolation, and the lack of familiar earthly cues could be profound. We would need to create a self-sustaining ecosystem within the spaceship, complete with artificial gravity, to simulate the conditions on Earth as closely as possible. This would require advancements in fields like bioengineering, agriculture, and psychology. Section 8. Future technologies, fusion power, and beyond. While the challenges are daunting, human ingenuity should never be underestimated. Scientists are exploring new forms of propulsion, such as fusion power. Fusion is the process that powers the sun. It involves fusing atoms together, releasing enormous amounts of energy. A fusion-powered spacecraft could theoretically achieve speeds that are a fraction of the speed of light, significantly reducing travel time. However, fusion power is still under development and faces many technical hurdles. Section 9. Conclusion, a journey for generations. Traveling to another galaxy is an ambition for the distant future. It's a journey that may take many generations. However, the pursuit of this dream inspires us to push the boundaries of science and technology, leading to new discoveries and innovations that benefit humanity here on Earth. While we may not reach another galaxy in our lifetime, even contemplating the possibility expands our understanding of the universe and our place within it. The human spirit of exploration, combined with scientific progress, will continue to drive us to explore the cosmos and unravel its mysteries.